because a lot of the topics in our last lesson came out to be really similar, let's try some different methods. The first thing we can change is using the TF-IDF vectorization of our text, as opposed to just the bag of words model. We're going to be using latent semantic analysis, as opposed to latent Dirichlet allocation, to see if that gives us different results. For this lesson, we're going to be creating a couple of different functions. The first thing we want to do is define a function to create our TF-IDF corpus. So we start by defining this function, TF-IDF corpus, and the argument it should receive is a document term matrix. The next step is to create the TF-IDF model. This takes the arguments of the corpus, which is our document term matrix, and normalize equals true. We then create our corpus TF-IDF, which is the TF-IDF doc term matrix. Our function will then return this corpus for us. We then want to create a function to get the coherence scores, so we can find the most optimal value for our number of topics. So we define the function getCoherenceScores, and the arguments it wants to receive are the corpus, the dictionary, the text, the minimum number of topics, and the maximum number of topics we want to test. We'll then create an empty list for our coherence values and an empty list for our models list. We then create our for loop, so for num topics I, in range min topics to max topics plus 1. We create our model using the LSI model, which takes the arguments corpus. The num topics will be set to the num topics I for that iteration of the for loop, and the ID to word will be our dictionary. We then append this model to our model list. The next step is to create the coherence model, which will take the argument of the model, the text, the dictionary, and the coherence, which we set to C_V. We then append the coherence model.getCoherence to our coherence values and create a plot. The plot will be plotting the number of topics against the coherence values. We also add the appropriate X label for the number of topics, the Y label for the coherence score, the legend, and we want to include PLT show to make sure our plot is printed out correctly. So now that we've defined our functions, let's create our TF-IDF representation of the text. So we create our corpus TF-IDF fake, and this equals TF-IDF corpus, which is the function we created earlier, and then we provide it with our doc term fake, which is our document term matrix. From here, we can get the coherence scores using our getCoherenceScores function. The corpus is the corpus TF-IDF fake, our dictionary will be dictionary fake, our text will be fake news text, and we'll use the same arguments as our last lesson. So our minimum number of topics will be 2, and the maximum number of topics we want to try will be 11. Now we have our coherence scores, we can see that the optimal number of topics looks like it will either be 10 or 7. Let's now create our final model. So we specify our LSA model, and we use the LSI model function. We feed it the corpus TF-IDF fake, our dictionary fake, and we set the number of topics to 7. So our first topic seems to have the words Trump, Clinton, and Hillary. The second topic, boiler, ARC, room. The third topic, Flynn, immunity, Nana. And again, if you read through the topics, you can see there's a lot more differences here compared to when we ran it in the last lesson. These are much more interesting topics to discuss and dig into what these differences are around the different topics and what that might mean. So when you're presenting this back and answering the question, what are the different topics appearing in fake news? This is something that you can present and talk about the different themes that are coming out of this text and the different things that are being discussed.